Today, let me start with a binary arithmetic session. So, these are useful to calculate your complements and to perform your binary addition, subtraction, as well as the multiplication. So, now let me start our session with our binary arithmetic. So, what are the rules we have for addition, subtraction, multiplication? And with a simple example, let I explain you each operation. Now, so there are a few binary rules to perform your binary addition. So there are four rules we have it in binary addition, and it was very easier than your decimal addition since we have only two values 0 or 1. So 0 plus 0 will give you the summation of 0. 0 plus 1 will give you the sum is equal to 1, and 1 plus 0 is summation bit is 1, whereas 1 plus 1 is equal to 1 0. As here it is a single bit addition, but at the result you have two bits. So out of that two bits, the most significant bit is considered as the most significant bit which is considered as a carry, and the least one is considered as a summation. So this is considered as a carry, and the least significant bit is considered as a summation bit. So 1 plus 1, as we already learned, what is 1 plus 1 in your decimal is 2. So if 2 in decimal is equal to, in binary it would be 1 0. It would be 1 0. So 1 0 to the base of 2. So least significant bit 0 is considered as sum, and the second bit is considered it as a carry. So wherever you have your 1 plus 1, so you need to take that summation bit must be 0, and you need to forward a carry of 1 to the next higher most bit. So this is very important rule, so that we have to proceed in binary addition. Next, let me move with the binary subtraction rules. Like in addition, four rules we have in the same manner. Here also we have four rules. So based on the possible values of your binary. So let me start with the combination 0 0. So now 0 minus 0 is subtraction result is 0. 1 minus 0 is the subtraction result would be 1. Where 1 minus 1 is 0, and 0 minus 1. So if I take a borrow from my next most significant bit position, then my difference is 1. If I take a borrow of 1 from my higher most significant digit, then only it will be possible to subtract this 1 from 0. If I take a borrow from your next most significant bit, so then only it become 2. So 2 minus 1 it become 1 is the difference with a borrow of 1. So this one is your main rule while you're doing your subtraction. So wherever, if you have a 0 and when you wanted to subtract a 1, so then you need to take a borrow from your next to most significant position and consider when the base power is moving from higher position to the lower position. Since the binary is having a base of 2, so we are going to add 2 to that particular position where you are subtracting the bit, and 2 minus 1 now it become 1 with a borrow of 1. Your difference is 1 with a borrow of 1. So next, binary multiplication. Comparatively with the decimal multiplication, it is the easiest version of your multiplication. So 0 into 0 is product is 0, 0 into 1 is 0, 1 into 0 is 0, 1 into 1 will give you the product is equal to 1. So now using these all the rules, let me discuss about the binary addition with a simple example, subtraction as well as your multiplication. Now, so here we have taken binary addition with a simple example of 6 bit of A. A is equal to with a 6 bit I have taken, and B with a 5 bit we have taken here. Now let me proceed with the addition in a column wise. So now let me arrange the given two numbers based on their positional weights. So now here first let me start the addition from your least significant bit position, and then we will move one by one positional bits towards to the most significant bit positions. So now let me start with the 1 plus 1 as we already learned. So in a binary rules, 1 plus 1 will give you the 0 summation with a carry of 1. And then now forward carry from your least to the most. So we are going to consider that too for addition of your remaining bits. So 1 plus 0 plus 1 will give you the summation is 0 with a carry of 1. Now here we have 3 ones. So now in order to add 3 ones, so let me take the 3 ones. So if I add 3 ones, the decimal equivalent become 3, but the binary equivalent of 3 is equal to 1, 1. So now as we discussed that 1 plus 1 is 1, 0, in the same one which is equal to 2, here 1 plus 1 plus 1, 3 ones we have. So the actual value in decimal is 3, the binary equivalent is 1, 1, 1, 1. So now least significant bit is taken as the sum bit, and your the second bit is considered as a carry bit. So hence in this case, so we have taken the summation bit is 1 and we forward a carry is 1. So now again we have 1 plus 1, so which is equals to 0 summation with a carry of 1. So 3 ones, so hence summation bit is 1, carry bit is 1. So 1 plus 1 is 0 with a carry of 1. So this is your addition of your given two numbers where the decimal equivalents are 61 and 23 is equal to 84. It's the decimal equivalent 1010100 is the decimal equivalent of your 84. So next binary subtraction. So using the four rules, let me proceed with the binary subtraction. 1 minus 1 is 0. Next 0 minus 1. So as we don't have any number here, 1 here, so I need to take a borrow from my next to most. This is my next to most. So when a borrow is forwarded here, the positional weight is equal to 2 square. When it is moving towards to this, so then you are going to add 2 here. You are going to add 2 here. Like in your decimal, so subtraction, decimal subtraction. So now I have 47, and from this 47 I wanted to subtract 8. So 47 is my decimal number, 8 I need to subtract from 47. So while you were performing this subtraction in decimal, so as this 8 may not go, so we are taking a borrow from my next to most. So now this is the position of 10 power 0, 7 is with the positional weight of 10 power 0, 4 is placed at 10 power 1 position. Now when a positional weight is moving from highest most to the next lowest most position, so then there was a difference between these two is this is 10 power 1 and this is 10 power 0 which is equal to 1. So there was a difference between this two is positional weight difference is 10. So hence we were taking a 1 from your next most, but while it is coming to this, it become the 10. So 10 plus 7, it is 17. 17 minus 8 now. So we are doing the subtraction. 17 minus 8 become 9. And the left here on your next most is 4. We are going to subtract 1 from your 4. So then you would have your 39. So in the same manner here, when you don't have any number on this position, we were taking a borrow from your next most and we were adding 2 here because binary is having a base of 2. So 2 plus 0 it becomes 2. So 2 minus 1 it is 1. Now, so as we have taken the borrow, so we need to subtract 1. So when I subtract 1, so then I have here 0. So now I need to subtract of this one from this 0. So I can't subtract it. So I'm taking a borrow from this, the next most. So when I take a borrow, then I'm adding 2. So 2 minus 1, it will be 1. Now here also I need to subtract 1. So there is no number now. So now 0 minus 0, now it is equal to 0. Next, 0 minus 1. So take a borrow from this. There is no number here. So I'm taking a borrow from my second highest positional number. So now from that one I'm taking a borrow, and then the borrow is forward from second bit to the first bit. So then here 2 minus 1 it will be 1, and left here it is 1. So 1 minus 0 is 1. Here left is nothing. So because already a borrow is left, so hence 1 minus 1 it is 1 is, we just cut that one, so and the remaining will be a 0. So in this way we are going to subtract your given binary numbers. Next, let me move with your multiplication. So now, since it is very easier, so you have been given with the A bit and B bit. So where A is the multiplicand and B is your multiplier. So by verifying its multiplier bits, so we are going to do the multiplication. So let me first identify how many number of zeros are there in my multiplier and how many number of ones are there in my multiplier. So your total product number of bits depends on the number of multiplicand and multiplier bits. The sum of your multiplicand and multiplier bits. So now, so the total partial products, how many we were getting is depends on your number of multiplier bits. As it is having in this example, it is having only 4. So we would have total 4 partial product. Now each bit of your multiplier is multiplied with all the bits of your multiplicand. If you have a 0, so how many number of multiplicand bits are there? That many zeros we have to place. And then second partial product must be substituted after or just by moving your partial product towards to the left, one bit towards to the left. So now I have second bit is 1, hence I need to copy your multiplicand. So 1 0 1 1 1. So next third bit is a 0. So how 5 bits are there in my multiplicand. So that many zeros with a shift of 1 bit towards to the left will be placed as or it is considered as a partial product 3. Next, last bit is a 1. So now the multiplicand is copied as it is with the shift of 1 bit towards to the left, and then these all the partial products must be added in order to obtain your actual product. So now partial products must be added here. So 0 will come as it is here, and 0 plus 1 it will be 1. 0 plus 1 is 1. 1 plus 0 is 1. Next 0 plus 1 is 1. 1 plus 0 is 1. 1 plus 1 0 summation with a carry of 1. Next 0 plus 0 is 0. 0 plus 0 is 0. 0 plus 1 is 1. 1 plus 1 is 0 with a carry of 1. Now 1 plus 0 is 1. 1 plus 1 is 2, and 1 plus 1 is 2 plus 1 is 3. So 3 equivalent is 1 with a carry of 1. So 0 plus 0 0. 0 plus 1 is 1 1. Here no carry is generated, so this one come as it is. Okay, so this is the actual product of your given two binary numbers. So this way we are going to do the binary multiplication. So next, let me move with your, this is about your binary arithmetic rules, and with a simple example I have explained how to perform the addition, subtraction as well as the multiplication. And the next two slides which I am giving here, it is an exercise of conversion of your number base conversion from one number system to the other number. Try to practice it. So here I have given the 33, which is a decimal number. You try to calculate the equivalent binary octal value as well as the hexadecimal equivalent value. Next, second bit is binary with a value of 11100101. So this is my equivalent binary. So for the such binary number, you try to find what will be the decimal equivalent, what will be the octal equivalent, what will be the hexadecimal. Next, I have given a 703, which is an octal number. Try to find its equivalent decimal value, binary value, hexadecimal. The last one, which is hexadecimal number system, number I have given 1AF. So try to find its equivalent in decimal, binary and octal. And the next slide too, I have given some few problems in order to obtain the result or to practice about your in-depth practice in your number base conversion. So try to solve all these problems and find its solution. Thank you.